Bismillahirrahmanirrahim. Assalamualaikum and good day. In this video, I'm going to explain several distribution that we are going to use in the next chapter, which is chapter 4. Okay, let's recall what we have learned before this. Okay, we have learned on normal distribution. Okay, so the normal distribution, we know it is bell shape and then it is symmetric for left hand side and right hand side, whereby for standard normal distribution, in the middle of the distribution is 0, which is the mean of the distribution. Okay, so we have another type of distribution which is T distribution, which is similar to normal distribution, but the difference is we have the alpha and V here. Compare with normal distribution. Okay, normal distribution, we have alpha here, which is the area under the curve of the bell shape, so which is represent the probability of normal distribution. Okay, for T distribution, okay, it's also bell shape and also symmetric, similar to normal distribution, and then also the middle is 0. So it is also, here is the negative value of T value, and here is on the right hand side is positive value of T distribution. So the only difference is now we have V. V is the degree of freedom. Okay, so V is degree of freedom. And how we going to calculate the degree of freedom is n minus 1. So the number of sample we minus 1. Okay, so for the distribution also the same. Here is the alpha, whereby the positive and negative value of the T distribution is symmetric, just like the normal distribution. So here we said that just now I said that we have alpha and V. So let's look at the table, how we're going to find the alpha or V, the T distribution, okay, by using the table. Okay, this is the T distribution table of the Modox table. Okay, we can see here that it is bell shape, and then the area under the curve on the right hand side is alpha. Okay, so alpha is on the horizontal value here. Okay, we can see that it is 0 something. Okay, so it cannot be greater than 1 because it is this probability. And then here we have V, which is the degree of freedom. Okay, so there are degree of freedom starting from 1 until 120. Inside here is the value of T. Okay, similar with Z distribution, which is the standard normal distribution, which is inside here is the Z value. Okay, now it is T value inside here. Okay, for example, we want to find T distribution alpha V, which is alpha is 0.01 and V is 10. So how we get 10 here is n minus 1. So here we know that the n is 11. So we have the degree of freedom is equal 10. So let's refer to the table. Okay, so first alpha is 0.01. So it is here. And then T is, alpha V is 10. So it is here. So 2.764 is the T value for this particular alpha and V. So if we want to draw the distribution, okay, so the alpha is here 0.01, and then the T value here is 2.764. Okay, so this is positive value. So because it is symmetric, so left hand side is negative, the same value but negative sign. Okay, so here is negative, here is the positive, and also the area here is also the same, 0.01 on the left hand side. Next is chi-square distribution, chi-square. Okay, chi-square also have alpha and v. But the difference is the chi-square is always positive value and it is not symmetric. Okay, we said that it is skewed to the right. Okay, so because it has the tail here which is not symmetric, it is skewed to the right. And then here it starts from the value of 0. So chi-square always has positive value. And then if we want to find the value, okay, this is the alpha here. Okay, so this is the chi-square value. So here is the area under the curve which is the represent the probability. And then the alpha v, okay, v is also the same degree of freedom, okay, just like the t distribution. Okay, so v equal to n minus 1. This is the chi-square distribution, okay, on the Modox table. Okay, this is chi-square whereby it, okay, just like what I drew just now. Okay, it is not symmetric. Okay, so here is the area. Okay, here is the alpha. So here is the alpha on the horizontal value. Okay, so it is so you can see that it is less than 1 because it is probability. And here we have the v on the vertical value. Okay, here all the value of the v, and also inside here similar with t, it is the chi-square value. Okay, let's say we want to find the value of chi-square for alpha 0.99 and the v is 10. Okay, the degree of freedom is 10. Okay, so 0.99 is here, the alpha, and then the v is 10. So here is the chi-square value 2.558. Okay. So if we draw the chi-square distribution, so here inside is the probability which is equal to 0.99, and then here is the chi-square should be larger than this lah because it is nearly 1 here, right? So the area is the probability, and then the value of chi-square here is 2.558, okay, which is the v or degree of freedom is equal 10. So this is the chi value. Area is 0.99, which is the probability. Lastly, we have F distribution. F distribution, we have alpha, and then it has 2 degree of freedom, which is V1 and V2. Okay, F is similar to chi-square where it is skewed to the right. And then it also always positive value, start from 0 here, and then it always positive, and then here is the alpha here inside the area under the curve. So for V1 is equal to 1 and 1 minus 1, and V2 is n2 minus 1. So basically here means that we have 2 samples. Okay, so the first degree of freedom is sample size, the first sample size minus 1. The second degree of freedom, sample size, the second sample size minus 1. So we have V1 and V2. Let's look at the table here. Table 9 is for the F distribution. Okay, so this is the distribution. And then on the horizontal value is the V1. And then the vertical side is the V2. And inside here is the alpha. Okay, we can see that every single combination of V1 and V2, we have inside here we have 4 value. This is the alpha. Okay, so what they are represent to, okay, you can refer in here. Okay, so the first value is 0.05, the second value 0.025, third 0.01, and last one 0.01. okay, which is in the bracket is 0.025. Okay, so the second value here, which is in the bracket, okay, like this one, all in the bracket is the 0.025. So for F distribution, we only limited alpha, which is only 4 alpha. Okay, so for example, we want to find the F value of alpha 0.05, and then the V1 is 10 and V2 is 3. Okay, so let's refer to here V1, V2. V1 is 10, so V1 10, it is here. Okay, then V2 is 3, so 3 here. So 3, and then here is the 4. Here is the 4 value of alpha. Okay, so now we want to find for alpha equal to 0.05. So refer to this one. Okay, 0.05 is on the first value. So it is here 8.75. Okay, we present the first alpha, which is 0.05. So if we want to change alpha equal to 0.025, so it on the second value, which is in the bracket, so 14.4. okay, so because it is the chi-square value, so it can be greater than 1. Okay, the probability is here, the alpha, so only 4 value of probability. So if you want to draw, so the alpha here is 0.025, okay, for example, and then the chi-square value is 40.4, okay, which is the V1 is 10, V2 is 3. So refer to this value. Okay, so you need to careful here. Okay, which alpha that you want to find, because the F distribution has limited value of alpha. So for example, if we want to find a greater alpha here, for example 0.95, okay, so it's given that this one minus alpha, so V1, V2 as usual, okay, this one. So actually this we can also find the F value by finding the inverse of this F value, whereby the alpha here is alpha, here is 1 minus 1, and then we swap the degree of freedom. Okay, V2 become the V1, V1 become the V2. Okay, for this example, okay, the alpha is 0.95, so 1 minus alpha is 0.95, so alpha is 1 minus 0.95, which is 0.05, and then V1 is 12, V2 is 18. So V1 is 12, V2 is 18. So now it changed. Okay, V2 become V1, V1 become V2. So we can write down as this 0.95, V1 12, V2 18 is equal to inverse of F 0.05. Okay, so V1 now is 8. It should be 18 here. Okay, and then the V1 become the V2. It is 12. Sorry, it should be here. V1 is 12, V2 is 8. Okay, not 18. Okay, this is 8. So this is okay, inverse of V1 is V2 now, it is 8, and then V1 become V2, which is 12. Okay, so let's refer to the table. Okay, we want to find the F value, whereby the alpha is 0.05, V1 is 8, V2 is 12. So 0.05 is the first value in the table. Okay, so 8 here, okay, is the B1, and then B2 is 12. So yeah, 12. So it is around here. So we take the first value, which is for alpha 0.05. Okay, so 2.85. So the value here is 1 over 2.85. So we obtain 1 inverse of the f value of the 0.05, 8 and 12. So we get the answer 0.351. In the next chapter also, we going to use this table, which is the percentage point of the normal distribution. Previously, we used the normal distribution table, which is in table 3. Okay, whereby here is the probability, and then inside here is the z value. Inside here is the probability, and then here is the z value. Okay, so we want to find the probability when we have the z value. Okay, so for the table 4, we have the alpha here, and then we want to find the z value. So it is different, but the same value actually, but it is arranged so that we can refer it easily. Okay, so here, for example, here is the alpha 0.03. So here is the z value. Okay, so it is similar. You can check or compare if you want to. Okay, but it is more easy to find the z value. Okay, here is the inside here is the z value. So if we have the alpha or the probability, and then we need to find the z value, so we use this table. Okay, table 4. Okay, compare with the table 3, we have the z value, but we want to find the probability, which is here, is inside here is the probability. So that is all the introduction on the distribution that we going to use. Okay, the table of the distribution in the next chapter, which is chapter 4. Okay, bye. Assalamualaikum.